Hello everyone, welcome back. This is 2-7 circuits, dropper hopper circuits in the compact redstone series. I'm MU222, and today I'm going to talk about, basically dropper hopper circuits and how you would apply them in your redstone builds. And I'll also go a little bit deeper about hopper ROMs. And yeah, so let's get started. I will talk about more about the properties of droppers and hoppers, because I quite frankly haven't covered all of them. And in case if you're watching this as your first video, I would highly suggest you to just refer back to 1-2 properties of redstone components 2, because it basically mentions a lot more properties about hoppers and droppers, and you should have a basic understanding of that. And it'll be great if you have a basic understanding, because we'll dive into things a bit more further. So yeah, let's just talk about droppers. There's only one extra property I want to talk of, and so it's basically when a repeater input powers several droppers, the power dropper, this one, gets processed first, and then the adjacent ones. And the adjacent ones, as you have probably known, they would be activated droppers. So we see we have an item here. So if we click this button, this repeater is going to try to power. It doesn't try to. It powers this dropper, but the dropper has nothing. So it activates these two droppers and processes them. So this has nothing, doesn't matter. This has something, so it would transfer one item to here. And then if I click the second time, you can guess what happens. The power dropper gets processed first, so this item will go to the top dropper, and then the adjacent ones, the activated droppers, will get processed later. So this gets processed, nothing here. This gets processed, there's an item here actually, so the item goes here, through here to here. So that's why you see the item ends back up here. There are no items here. So yeah, that is basically what the property is saying. And notice that I said a repeater input powers. Now, you don't have to make it an actual repeater input. You can have comparator, you can even have pressure plates. As long as it is not anything like redstone dust, this would be locational, or anything that has a different update order, like a redstone torch. So any other thing would be fine. Observer is fine. Just redstone dust and redstone torch for now, if I haven't missed out anything. So yeah. So that is about droppers. I will talk about hoppers now. So we know from 1-2 properties of redstone components 2 that a hopper has some functions. It basically transfers items from one container to the other container, but I didn't really specify anything about it. So let's just be more specific. A hopper has 3 functions. It can collect item entities. What do we mean by item entities? Well, if I drop this item here, the hopper will collect it. It also pulls item from a container above it. So say if I have a hopper here, so if I place one, it will go down. And it also would push items into the pointed container. So if I have another container here, I put items here, it will get to here. So these are some basic things that you probably have known, but then I didn't specify it specifically. And the reason why I specify it now is because of this later property. I will tell you now. So when a hopper is powered, all 3 functions I've mentioned just now are going to be disabled. So let's just analyze how it would affect in these 3 cases. So we have a chest, not a hopper, and then we have a locked hopper. We say a powered hopper as a locked hopper, by the way. And then we have another hopper that is not locked. So this hopper, it cannot suck, it cannot deliver items. Basically these two. Collecting item entities doesn't really matter. So as it cannot suck items from the top container, this sign will remain here. It cannot even transfer. So for this one you can see this hopper is actually pointing towards the redstone block. So again, it cannot suck, it cannot push items, but then let's just see what will happen. It actually goes down here. The reason is that this hopper pointing to this locked hopper, well, it is pointing to it, so it can send items to this. And when it sends items to this bottom hopper is actually able to suck items from this hopper. So even though this hopper cannot suck nor push items, these two hoppers can. So the item from here can transfer to here. Hence you have this, like this. But then, if you have this instead, well, guess what happens? This cannot suck, nor could it push, and this hopper is not pointing towards this hopper, so it cannot transfer its item to it. And that is also the reason why you see a lot of hoppers not facing towards the downwards direction. Instead, it faces sideways in a lot of hopper sorting systems. It basically uses this property. So there you go. These are the more in-depth properties of droppers and hoppers. You basically now would know how they would work in general. So let me go on to the next section, which would be just introducing you some basic dropper hopper circuits. I can tell you that dropper hopper circuits require a lot of creativity when you actually try to build one yourself, but then there are also some general ones that you should probably memorize. The first one will be a T flip-flop. You have seen this as always, and this is a comparator here. So make sure that you input this with a repeater input, because I've explained this in 2-1 basic locationality and directionality, that if you input this with a dust, it's going to be locational. So you don't want locational things to happen. So yeah, anyways, a repeater input will always guarantee this to work. So each button press, you're going to turn this on or off. A T flip-flop. Nice. The second one is just a rising edge monostable circuit. Doesn't really matter. You probably have seen this as always. And here it will also be good for me to mention some additional definition, is that if the item, or any items, or all items I should say, in the dropper hopper circuit is able to return to its original state after certain powering conditions, then the dropper hopper circuit is resettable. So let's just take this T flip-flop as an example. I press it once, it goes here. I press it twice, the item goes back to here. So after 2 presses, the item is able to go back to its original dropper. So we say that this dropper hopper circuit is resettable, and otherwise it will be non-resettable, basically. And there's also a common thing here, is that usually for any dropper hopper circuits, they will be reset to its original state after 1 closing and 1 opening. Usually. There are some very specific exceptional cases, but then usually it would be able to reset after 1 closing and 1 opening. So yeah, now we move on to some other circuits. So this one will be a bit more special. This is actually a counter. It counts 3 times. So press 1, this powers, press twice, this powers, press 3 times, this powers, press 4 times, oh, it doesn't power. There aren't any items here, whoops. So yeah, this is a counter. So after 3 times, it would stop powering. And the number of times you can power this actually depends on how many items you place into the dropper. So yeah, very customizable. And how to reset it? Well, you just basically unlock the hopper. That's it. And then all the items return here, and then it's fully reset. So again, this is resettable. Now we talk about this here. This is called the RS NOR latch. A more accurate name is actually SR NOR latch, because S refers to set and R refers to reset. So this is technically a set dropper and this is a reset dropper, but then no one really cares about these technical things. So just here to mention. So yeah, I will still refer to this as RS NOR latch. But anyways, so if I press this button, nothing happens until I press this button. This will power. And then if I keep pressing this button, nothing happens until I press this button. And then this will turn off. So yeah, RS NOR latch. You have seen these before. So yeah. I can tell you that RS NOR latch, besides, is useful for giving constant signal, it is also useful for creating long pulses, which you'll be attempting in an exercise. Should be quite simple actually. So moving on to another circuit. So this is actually an instant dropper line. Well, I say instant, although there are two observers here basically. Well, it's instance from the activation of observers. So there are items here, a lot of them. So you probably know that this rail is going to power this, then this, then this, and then the item transfers here. So click this, and item goes here. Nothing in between. It just goes straight to here. Straight to here. So instant dropper line. And if you really hate me saying this as instant, well, you can just build another circuit by yourself by using butts instead. So you want to power this dropper and then have this dropper being butted, and then have this dropper also being butted but with more bed than this, the amount of bed received by this one. So yeah, just increase in bed would be fine. So yeah. Now we come to a very similar one, except I just have these droppers in reverse and the hoppers as well. So what this will do is actually it will behave as a free state toggle. Where is my item? The item is here. Okay. So click this once. This item goes to here actually. Twice goes to here. Third time it goes through the hoppers and goes to here. I'll reset this. So yeah, a free state toggle. You can just add more rails, more observers to make this even more states of toggle. And as mentioned, these two are also resettable, because for this one, well, you can just power this dropper to reset it. And for this one, all you need to do is to power this 3 times and then power this dropper again. So fully resettable still. So yeah, and then the last one I'm going to show you is a simple dropper tower. I didn't really include the most advanced ones like instant or silence dropper towers, but then this already serves the purpose. So yeah, it just sends items. And you do want to remember this, because droppers are basically the only container that is able to send item upwards. Else you would need to use some very specific methods, and those are probably going to be too specific that I don't want to introduce here. You can obviously use some item elevators, but then that will probably cost you too much size or volume, so it's probably not worth it. So yeah, that is basically going to be the circuits I'll introduce you. And notice that in here I just introduced the very basic circuits, but then the creation of a dropper hopper circuits goes way beyond this. You can have some massive dropper hopper systems, and yeah, they would be useful according to how you implement it. So yeah, although we currently use more observers now, so dropper hopper circuits don't seem as useful, but then in some situations, for example, you might need a 3-state toggle, for example, then you would see dropper hoppers as being very useful, because you normally can't really make a 3-state toggle normally without dropper and hoppers. So yeah, that is going to be all the dropper hopper circuits I'm going to introduce. And before I go on to some of the next parts, I will introduce you some more definitions and some results from that. Is that if an item can loop around a dropper hopper circuit, then the circuit is a complete dropper hopper loop, otherwise it's incomplete. So let's just see this here for example. We can always power this dropper, this dropper, this dropper, and this dropper, and the item will just loop back. Well, we don't actually need to power this dropper. This is being sucked by a hopper. So yeah, just these 3 droppers. So this is a complete dropper hopper loop. You can even see that it's complete. It just goes around here. And otherwise, it will be incomplete, like this one. This, if I power this, goes to here, and you have no way to go back up. No way. So that is incomplete. And by the definition from the previous here, I said about resetting, and here the completeness of dropper hopper loops. So all incomplete dropper hopper loops are non-resettable, essentially, because items will definitely be lost. You cannot transfer it back up. Here as an example. And this also means that as the dropper hopper loop is non-resettable, it is considered as unlegit according to some regulations we have for making doors. However, it is recently being defined as legit, but only in some specific conditions. So the legitimacy of an incomplete dropper hopper loop can be achieved by any infinite item production farms, and that serves as the item refilling. So basically you can have any hopper and then connect it to any item farm you can think of to refuel the system. And the common way to do this is actually to use chickens. So we are going to introduce mobs to the door, in which some people would think is very impractical to do it, and probably I partially agree, but then hey, it still works. It's a legit method, so you know, we are progressive, so can't scare that much. But yeah, using mobs are legit in making doors, so you know. But yeah, just telling you that you can use incomplete dropper hopper loops and still be able to have your door classified as legit as long as you use any item farms. So yeah, that is all I'm going to give you for the dropper hopper circuits, and along with some useful definitions I've said throughout, I will go on to a bit more in detail to hopper ROMs, which I actually have done some mini research in it. So hopefully my findings would be interesting and useful for you. So let's just talk about the basics of hopper ROMs. So there are 3 kinds of items. Items can be 64 stackable, 16 stackable, or unstackable. And 64 stackable really means that the items can stack up to 64, like this. And 16 stackable would be stackable up to 16. Non-stackable or unstackable is you can stack them. And I also said probably in properties of redstone components 2, 1-2, that these items are going to have different values of item fullness. And the difference in item fullness is a very useful thing in Hopper ROMs, because we can create variations of Hopper ROMs, and the variations might cause some different delays or even different amount of pulses given. So yeah, I'm not going to explain too much in terms of that, but then yeah, if you still have more questions, you should probably refer to 1-2 again. So yeah, anyways, so let me just tell you a bit more, I guess. For 16 stackable items, there are actually not that many options. The common ones I can think of are snowballs, ender pearls, and eggs. Probably there are still a lot more, but then I can't think of any of them. So these three are the most common ones that you are going to see. So yeah, it should probably be enough for you on your own use, because hoppers have only 5 item slots and 3 is sufficient enough. So yeah, and let's just jump onto the example, I guess. So there are 3 circuits here. This one has 46 items, regular items. This has 12 snowballs. This has 3 shovels. These 3 circuits all produce 3 pulses, but then you can look at the pulse frequency. The video is still running. Yes. Yes, it's still running. Yeah, it's quite slow. I know. So you can see, to have all the 46 regular items to just pass through, it takes forever. Now let's look at the case for snowballs while we wait for this. So this is significantly faster and more frequent as a result than this one. So yeah, you can see the pulse frequency difference here. And if I use 3 shovels here, well, it's just too speedy. The 3 pulses is done. So you can see that by using different stackable items or non-stackable item, you can create different pulse frequencies. And that is why the combination of these 3 are super powerful. Because for regular stackable items, you would need longer time for them to accumulate to the next signal strength, while for a 16 stackable item, you would have essentially 4 times the speed. And for non-stackable items, well, 4 times again. So you can always use different types of stackable or non-stackable items to achieve the delay you desire. And in addition, you can also use different combinations of them to make your own customized Hopper ROM to fit in for your delay. So that's basically what I'm trying to say. And now I'm going to talk about 3 important concepts for Hopper ROM creation. The first one is that there are 2 main types of Hopper ROM output detections. Either you would detect signal strength via redstone dust, or detecting signal strength threshold. So what do I mean by that? Detecting signal strength change is pretty straightforward. You've already seen that just now. There are 3 changes to the signal strength, so 3 pulses here. But then when we're detecting signal strength threshold, we're detecting if this has enough signal strength to power certain things. So for here as an example, I have 8 items here. So this is detecting a signal strength of 1. So as long as it is lower than 1, it will turn off. And yeah. So detecting via signal strength threshold basically only means that you are, first off, receiving constant signal or off constant signal, and second off, you're going to only have one change. And I guess a better example here would be to have, let me think, snowballs. 11 snowballs, let's just say. Goodbye. So, also notice that 6 snowballs is enough for signal strength of 2. So you need to have 5 items to leave before the 6th item, which will depower this piston. Okay, cool. But then, when we flick the lever back, you would again need 6 items in order for this one to power back. So at signal strength of 1, this doesn't power yet. But then at signal strength of 2, this will power. So that's where I mean by signal strength threshold. Because we don't want it to just power whenever this comparator powers. That sounds very meaningless. But then, when the signal strength reaches enough to a certain point, we want things to power. So that's why I say the threshold. So as long as it reaches signal strength of 2 in here as an example, then this will power. Like so. And you can also use basically this to create some different delays. So here we can use this signal strength of 2 to have it such that when we flick the lever, this will basically turn off quite instantly. And then when we turn it back off, this will take a while before it can extend. So essentially sort of an arbor concept. So yeah, hopper ROMs are also sometimes useful in creating some arbor circuits. Okay. And okay, let's move on to the second concept. Is the concept of placeholder items. Placeholder items are useful in generating delay between signal strength changing items. So here we see shovels here, and then shovels are essentially signal strength changing items because they correspond to an increase in 64 regular items. So it definitely is going to increase signal strength, definitely, because hoppers, they increase signal strength by 1 signal strength by 22 or 23 items. So wooden shovel definitely going to increase. And you can see how the placeholder items come into play. Remember that this has 3 shovels only, and it just goes speedy. These 3 pulses are literally just so close to each other. Well, now with the introduction of placeholder items, look at what happens. You see? So the pulse frequency immediately decreases because of the placeholder items creating delay. And comparing to this, you can already see it. And yeah, that's where the placeholder items come into play. And as long as you can ensure that the placeholder items do not cause any disruptions to the hopper ROM, they're fine. Also notice that I place 4 here because if I place the 5th one here, it's going to make a change because 69 items actually is equivalent to 4 signal strength. And that will cause a change in signal strengths. And if we don't want that, we want to limit this as 4. So yeah. And the last concept is that different types of items are used to avoid any mix-up of stackable items, which you already see here. For regular items and for also regular items, but differently. Because if we have 4 like this, look at what happens. Yeah, it's going to be funny because it's going to have these 8 items being stacked together, of course, because why wouldn't it? And that's why you need to have a mix-up of different regular items or different 16 stackable items. And yeah, use different types of items to avoid mixing up of them. And here I'll just show you a bit more Hopper ROMs. So this one is 16.6, 1 and then 1 and a Pro. This actually has a very similar effect to 16 snowballs and 7 snowballs, so 23 snowballs. But then we add a placeholder item to add just the item delay. Now this is actually used in one of my, not doors, but extenders. Yeah, it should be the extender for the upwards quadruple flush and seamless one. I forgot which size it is, but then yeah, it's one of them. So this specific item here creates an extra delay between this posing item and the previous ones. So yeah, and then another one would be this here. This is a bit more special Hopper ROM. Actually, you don't really see this that common. This is let me just show you. Okay, so what this does is basically, first off, we detect signal strength threshold. We detect literally from the dust, not from observer, and not directly here because it will be meaningless because all of the items at least have signal strength of 1. So we want the shovels to pass through and not the regular items. And this configuration means that only the shovels will power this piston. So that's why you see a shorter pulse and quite a longer pulse. And I probably haven't reset it long enough such that it breaks. Yeah, let's just see it again. A short pulse and a longer pulse because the 2 shovels are literally right next to each other. So yeah, and I can tell you that why this isn't that common is because this should not be placed like this. Instead, there would be 2 minecart chests connecting these 2 hoppers. These 2 should be minecart chests. And the reason for minecart chests is more storage. You usually want more storage for this kind of system. So yeah, I would only introduce minecart chests or other minecarts usage in, I think it should be 2-10 basic entity usage and entity circuits. So yeah. Lastly, I'm going to talk a bit more about some simple definition and properties again. So the first off is the concept of, not concepts, the meaning of symmetrical Hopper ROMs. So symmetrical Hopper ROMs refer to Hopper ROMs that have the same types of items when reading forward versus backward, like palindromes, if you know what palindromes are. And otherwise, the Hopper ROMs are considered to be asymmetrical. So let's just look. This one, is it symmetrical? Yes. This and this are the same. Is this symmetrical? Yes. If you consider it like this, then you can see it's the same. Is this symmetrical? Well, you see this side wall and this side stained glass. Actually, it's still symmetrical because this matches this matches this in between we don't really matter. It's the axis of symmetry. Is this symmetrical? Well, if it were to be 16 and 7 snowball, it would be symmetrical, but then now we have an extra cyan wall here as a placeholder item, then no, it's not symmetrical. Unless, if you do something like this, then it will be symmetrical. Obviously, you want this as another item, but that's just showing you. So this will be asymmetrical. And is this symmetrical? No. This 4 doesn't... It's not symmetrical to this wooden shovel, of course. Even though this is symmetrical to this. This itself is symmetrical. This doesn't match this. So, asymmetrical. And yeah. So why do we care about symmetricalness? That's because of this property. All symmetrical hopper ROMs provide the exact same pulse frequency when activated versus deactivated. And another property is that all symmetrical hopper ROMs provide the same. Besides the same number of pulses, they would provide it with reversed pulse frequency. So it's a bit harder to explain why is a reverse pulse frequency, but you can think of it by intuition. Say for this one. So for any pulse frequency here, it will be repeated by having these items getting removed first. And that's basically just reverting the process. And the reverting of this process will cause a reversed pulse frequency. And some of you might be confused. Why is not the same pulse frequency? Is related to how signal strength works. Because signal strength is not a function that increases the same. As I've already said, sometimes it increases by 22, sometimes it increases by 23. So, not stable. And in addition, the use of our stackable and non-stackable items also cause difference in pulse frequency. And this causes a lot of changes. So although sometimes symmetrical hopper ROMs can have the same pulse frequency when activated versus deactivated, it's not always. What is always is that the pulse frequency will be reversed, considering activated versus deactivated. And I don't want to prove this for too long, so I'll just stop here. And hopefully you will understand it a bit more by intuition. Before I move on to the exercises, let me just introduce you to some useful resources. The first one is Hopper Hash, or some other people will call it Hopper Aging. This video is by XCOM 6000. The link is in the Word document, which will be in along with the world downloads the file. And yeah, you can always check this in the description below. Why it's important to have this as a resource is because it explains an important, we can say, bug for hoppers. And that's also the reason why people divert away from using dropper hopper circuits for tight timings. It's because when you reload a world for hoppers that are not in spawn chunks, the hopper update order gets messed up. And this will cause some discrepancy in timings that will affect how the dropper hopper circuit is supposed to behave. And if you're relying on tight timings, then your contraption will break. So that's why we quite often, or sometimes for some people, divert away from using dropper hopper circuits. Or we can still use them, but then we don't want to depend on its timing, basically. The second resource is actually a Python program written by me using extremely limited programming knowledge. So don't judge my programming skill, I guess. I mean, if it works, it works. So the program, what it does is it actually analyzes how hopper ROMs behave. This will be useful in one of your exercises. And to ensure that you know how the program works, I also will include a video link in the description perhaps below. And the Python file is also available for download along with the Word download stuff and the Word documents. So yeah, there you go. And the third resource is actually in the Word document. I have already sent this out before. It is, again, the Minecraft Wiki's minimum items for container signal strength. This is already been shown in 1-2 properties of Redstone components too, but then just for your reference, I have also included this in the Word documents for your easier reference. So anyways, after a long video, I guess, we'll go on to the exercises. The exercises are interesting. So let me just mention this question first. This question actually is basically the same question from 1-7 should be 1-7. I already forgot what it is, so let me just check. 1-7 is basic circuits, pulse extenders, multipliers, and clocks, because quite frankly this hopper ROM is a pulse multiplier. So I've already included the question there, but then there are 3 remainder questions that I've considered as challenging in 1-7, but now I don't consider because I've already taught you a bit more about hopper ROMs. So it's the sub-questions E, F, and G. So you can refer to the video to learn to revisit the concepts about hopper ROMs to answer the questions. So this shouldn't be too hard for you now. And I've also removed some redundant questions that are only applicable to 1-7. So yeah. And as I've mentioned, for the RS knowledge, the exercise is here. You can just refer to the question. It's actually quite simple. So no worries on that. The first question is just to tell you to fit in suitable amount of items to make these two pistons power at the same time and D power at the same time. It's very simple. The second one is a bit more interesting. Using these resources, you want to build a 3-state toggle. This observer here is useful for a reason, by the way. And I guess I'll talk about the 6th one first. The 6th one is taken from a real door from me. It's basically just asks you, well, 2 of the questions are asking you some yes/no questions. Identify if the drop hopper circuit is a complete loop, and identify if it fully resets. So, you know, those kind of stuff. So very simple, straightforward. And it's just B and C. Explain how the item moves during the closing and opening. So you want to see how these observers, the stuff, power the drop hopper circuit, and then such that the item moves. So you just want to explain a bit. You don't have to explain it too much in depth. So yeah. And this here might be a bit confusing. Identify the type of dropper hopper circuit by considering the behavior of dropper hopper circuit with respect to the input. So what I'm saying is from the input to the output of this comparator, for example. So what the dropper hopper does. And then for sub-questions F and G, they're basically just asking you some advantages of using the dropper hopper circuit. So the statement here, you need to consider it. And then from this statement, you want to state the advantage based on the statement. So another statement here. So based on the statement, suggest another advantage. So yeah. Don't worry if you don't know how to do these exercises, because there will always be solutions, and the solutions for the word for the worthy ones, they will be included in the file again, along with the Word download and the Word documents. So, that file. So, yeah, anyways. The most interesting one is actually 7.3. This is a very challenging question, even though it literally just tells you to fill in the hopper. It is that by using the correct configuration of items, you want to make the hopper ROM produce 3 pulses on one edge and 2 pulses on the other. And one restriction is that any 2 pulsing items must have at least 4 items in between. So what do I mean by that? Well, a good example would be 6 snowballs. So for the 6 snowballs, the first one and the 6th snowball will always be the pulsing item. So what this means is that the 2nd to the 5th snowball are going to be the items in between. And 2, 3, 4, 5, you can count it, there are 4 items here. So that's the minimum I want you to have. And as long as it's greater than or equal to 4, it's fine. Just don't be less than 4. This is a challenging question because you probably haven't learned about the techniques of asymmetrical hopper ROMs, especially in this unbalanced pulsing hopper ROM. But then I have given you some hints. So the first hint, shuffles guarantee signal strength change. And the second one, let the total items in the hopper ROM be barely below the next signal strength change. The third one is just a suggestion. Use all types of stackable or non-stackable items. So hopefully you would get some concepts behind this. And I say this is hard because this is actually part of my research. And this is one of the findings from the research. And don't worry, the answers are still behind this Blackwood wall. So you can always refer to it. But then, in case you don't want to give up yet, well, remember that Python program that I have said before? Well, it's actually useful in this exercise because it will provide you how your hopper ROM behaves given some items that you have placed it. And I have made an additional video explaining how the Python program works. So if you want to try this question out, I would suggest you, first off, download Python. Second off, just look at the video and see how it's going to work. Although I probably expect nobody would do that. But then, anyways, it will be... The Python program not only is useful for this exercise, but it's also useful for other analyzing stuff for hopper ROMs. So, yeah, I will explain more during the video. I don't want this to be too long. And yeah, good luck with the exercises, and I hope you learned something from it as well. So, anyways, that will be enough for me. Thank you for watching. I will see you in 2-8. Let me see what 2-8 is. Circuits, miscellaneous circuits. So yeah, I'll see you there.